Hello there, welcome to the October 2020 applied paper. Here we're looking at the fourth mechanics question. A ladder AB has mass m and length 6a. The end A of the ladder is on a rough horizontal ground. The ladder rests against a fixed smooth horizontal rail at the point C. The point C is at a vertical height 4a above the ground. The vertical plane containing AB is perpendicular to the rail. The ladder is inclined to the horizontal at an angle alpha, where sine of alpha is equal to 4/5, as shown in figure 1. The coefficient of friction between the ladder and the ground is mu. The ladder rests in equilibrium. The ladder is modelled as a uniform rod. Using the model, show that the magnitude of the force exerted on the ladder at the rail at point C is 9 mg/25. Okay, so I'll move on to a page just with a little bit more space. So the first thing I need to add to the diagram is halfway up the ladder we have the mass. So it's going to be mg at that point there, so the force of the ladder at that point there, and it's going to be 3a up the ladder. A good thing to do now would be to work out how far up the ladder this point C is equal to. Now if we have a right angle triangle with 4 on this side and we don't know what the hypotenuse is, the 6 value will go all the way up to B, but we want to work out the point from A to C, and we know that sine alpha is 4/5. Then sine is the opposite over the opposite over the hypotenuse value, so it's going to be 5 at that point there. So this length from A to C is 5a, so therefore it's 2a to this point here and another a value up to point B. So that's an important value. We're told that the ground at point A has friction, so there is going to be a reaction force at that point, and there is going to be friction acting in this direction. Why will friction act in that direction? Well, because if we just leave the plank resting there, it's likely that the plank will want to slip downwards to the left, so friction will have to act in the opposite direction. Okay, so we've got a lovely diagram there. Now let's start doing some maths with it. So we first want to work out the force exerted at rail C, the reaction force. That's going to be this force here, the reaction force at C. So in fact, let's do it, the reaction force at A, reaction force at C. Let's label it like that. So what we're going to do now is we're going to take moments about point A. That will leave us with a 0 distance to these two forces here, which will eliminate them from this equation. Now the first thing we have to do is work out this perpendicular force here. Now if that's alpha, then this is going to be alpha, so this is going to be mg cos alpha. So mg cos alpha is going to be equal, so times the distance, because it's a moment we're working out there, times 3a, will equal the RC force times 5a. Okay, let's cancel out the a's on both sides first of all. So it's going to be mg cos alpha. Actually, you could work out what cos alpha is equal to. Let's use this 3, 4, 5 triangle down the bottom. That would be 3 there, and cos would be adjacent over hypotenuse. So the cos alpha is going to be 3/5. Then we've got to multiply by this other 3, and that will equal 5RC. And then when I divide by 5 onto the other side, in total we're going to get 9 mg. We've already got 5 on the bottom, we're dividing by 5 as well, so that's going to be 25 equals RC. So there we are, that's the answer for part A. Let's just clear the diagram a little bit. So let's now move on to part B. Hence or otherwise, find the value of mu. Okay, so what haven't we done so far in this diagram? Well, we haven't involved this RA force and this RC force. Now, we all know that friction is equal to mu R, but that's equal to RA. So what we might want to do first is resolve our forces up and down, or maybe left to right. Either one of those would be fine, probably both. So resolving the forces up and down. Now at this point we're going to ignore this mg cos alpha force. That was this initial force here, mg, resolved. So I'm going to ignore that now, but I will need to resolve this force here. So So if I resolve it this way and this way, then by the z angles, this angle here will be alpha, this angle here will be 90 minus alpha, so then this angle here will also be alpha. So the resolved force going upwards is going to be RC times by cos alpha, and this force here that will be eventually used for resolving horizontally will be RC sine alpha. We know what RC is equal to now, so we'll use that when we bring it in. So resolving up and down then, so we have the R force acting up, this RA force, and we also have RC cos alpha. So that's going to be add 9mg over 25 times cos alpha, which was 3 over 5. And that's going to be equal to the downward force of mg. So let's simplify this fraction here and work out what RA is going to equal. So therefore RA is going to equal 27 over 125, and then we'll move it on to the other side. So let's do that on the calculator. 1 minus fraction 27 over 125, and that gives us 98 over 125 mg. So that's the value of A. That's the value of the reaction force A. Let's now resolve horizontally to get the value of friction, and then we'll combine it with F equals mu R. So the force to the right is going to be the friction force, and the only other force that's acting to the left is this RC sine alpha value. So RC is 9mg over 25, and sine alpha was 4 over 5. So that will simplify to 36 mg over 125. So now we're going to combine this together with F equals mu R. So the F is going to be 36 mg over 125 equals mu times R, which is 98 over 125 mg. So yeah, we can see this cancelling out quite easily here. The times both sides by 125, divide by m, divide by g, divide by the 98 onto the other side, and we get 36 divided by 98 equals our value of mu. And let's just simplify it for a final answer. 36 divided by 98 is 18 over 49. Lovely, so there we are. That's the answer for part B, and that's the final answer for question 4, worth a total of 10 marks there, mu being 18 over 49. Let's now move on to the final question of the paper, the fifth mechanics question.